Good morning, students. Today we are going to see the unit 4 thermal radiation. So we have come across the modes of heat transfer, conduction, and convection. So now the topic is radiation. So we generally know that heat transfer is taking place due to temperature difference. So heat transfer is a boundary phenomenon and it takes place due to temperature difference. Similarly, the radiation will also takes place due to temperature potential, but the one thing it is differ by one thing it differs, it does not require any material medium. Where conduction convection is required a material medium to transfer the heat. But in case of radiation, it does not require any material medium to takes place. So now, where the radiation will takes place? The radiation will takes place in any body if the body temperature is above 0 Kelvin. Suppose if you take a box, if you take any box, it may be copper box or aluminum box or any box. Suppose if the temperature is above 0 Kelvin, definitely that box will emit a radiation. Even our body, the human body, generally human body has a temperature above 0 Kelvin, so the human body will also emit a radiation. Mouse will emit a radiation. One important thing, for example, how the snake will capture a rat. The snake will capture a rat with help of radiation emitted by the rat. So all the bodies in universe will definitely emit a radiation when their temperature is above 0 Kelvin. And if you take any two bodies, if the two bodies are two mediums, if the two mediums has the same temperature, if the two medium has same temperature, it will emit the same amount of radiation. If it is emitting same amount of radiation, the net radiation between the two bodies, the net radiation transfer between the two bodies will be zero. That is stated here. Even though the temperature of medium are same, both the mediums emit radiation toward each other, but the net radiation heat transfer between two medium is zero. So next, radiation is taking place through an electromagnetic waves. So radiation is in the form of electromagnetic waves or electromagnetic radiation. So we need to know what is in the electromagnetic waves. So electromagnetic waves means in a chemistry we have read K shell, L shell, M, N, and all the shells we know. We know that in each and every shell there will be an electron will occupy. Suppose if an electron is moving from one orbit to next orbit, it's moving from L shell to M shell, it will liberate an energy, it will release an energy. So that energy is named as electromagnetic radiation. So electromagnetic waves and electromagnetic radiation represent the energy emitted by a matter due to change in electronic configuration of atom or molecule. That is called electromagnetic waves. So next, radiation heat transfer may be volumetric phenomena or surface phenomena. Surface phenomena. So now what is meant by volumetric phenomena or surface phenomena? For example, if we take a solids and liquids, the radiation will come across will be emitted through the surface. But if you take a gases or transparent body, gases can be called as transparent body. It will occupy the volumetric phenomenon. That is called volumetric phenomenon will takes place in transparent bodies, whereas surface phenomena will be taking place in solids, liquids, and opaque surface. Example, wood and rock. So next we have to see what is the quantum or Planck theory. So quantum, it is stated that the radiation energy which is emitted or absorbed by the black body is not continuous but discontinuous in the form of small discrete pockets of energy. Each such a pocket of energy is called as quantum. So this quantum or Planck's theory means every body above 0 Kelvin, if the body is above 0 Kelvin, it definitely will emit a radiation. But the radiation will not be in a continuous form, it will be in a discontinuous form. So it will be in a discontinuous form. At the same time, it will be in form of discrete pockets. This is called discrete pockets, discontinuous and discrete pockets. And this discrete pockets is named as quantum or quantum energy. And this energy, the quantum energy, is directly proportional to frequency of the radiation. That is, the energy of each quantum is directly proportional to frequency of radiation. It means each and every quantum will have certain energy, and that energy is directly proportional to frequency of radiation. So, what is the frequency? The frequency can be defined as The speed of propagation of wave in any medium. The speed of propagation of wave in any medium with respect to wavelength in micron. That is called frequency. The frequency is indicated by a symbol called mu, and E is called as a radiation energy. So E is directly proportional to frequency. And this term, when we convert it into equal to symbol, we need to add a constant. That constant is called Planck's constant. E is equal to Planck's constant into frequency. So frequency can be elaborated as h into c by lambda. C for speed of propagation of wave, lambda for wavelength. So we can also state that from this Planck's equation, we can state that the radiation energy, E is called radiation energy. The energy of quantum, the energy of quantum is inversely proportional to wavelength lambda. It means the energy of quantum increases when lambda, when the wavelength is decreases. When the lambda increases, when the wavelength increases, the energy of quantum decreases. Shorter the wavelength, longer the energy. So lambda is called wavelength. Wavelength has an unit micron meter. 1 micron is equal to 10 power minus 6 meter. So next, thermal radiation and wavelength band. So this type of electromagnetic radiation that is relevant to heat transfer is called thermal radiation. So in a universe, there are n variety of radiations are available. N number of radiations are available. But if thermal radiation means due to the radiation, if any heat transfer is taking place, any heat transfer relevant properties are taking place, then we call it as a thermal radiation. So thermal radiation is emitted by all the surface whose temperature is above absolute 0 Kelvin. So it means higher the temperature of surface, higher will be the thermal radiation emitted by the surface. For mechanism of thermal radiation, we will see the mechanism of thermal radiation. So now I'm going to take a two surface, surface 1 and surface 2. Consider surface 1 has a certain temperature T1 and surface 2 has a certain temperature T2. Now this surface will have some heat energy. This heat energy gets converted into electromagnetic waves. At stage 1, the heat energy at the surface 1 is converted into electromagnetic waves. And this electromagnetic waves will starts to propagate, or it will starts to move from one location, from this surface to another surface. It does not require any medium. So whatever the medium is present between these two surfaces, it will propagate through the medium. Even if there is no medium, it will propagate. Suppose the two surfaces separated by a air, then through an air, the radiation will take place. Suppose if the two surfaces separated by a water, then this propagation, the electromagnetic waves will propagate through the water. Even if there is a no medium, without medium also radiation will transfer from surface 1 to surface 2. And this electromagnetic waves will transfer from surface 1 and strike the surface 2. At the stage 2, at stage 3, when this electromagnetic waves strikes this, when this electromagnetic wave strikes this surface 2, it will get converted into heat energy. This is a mechanism of thermal radiation. So next, thermal energy is a portion of electromagnetic wave spectrum in wavelength ranges from 10 power minus 1 to 10 power 2. So only this wavelength having electromagnetic waves will generate this heat energy 10 power minus 1 to 10 power 2. It is called as thermal energy or electromagnetic wave spectrum. Thank you.